So guys, in today's video we are just going to continue the remaining methods for the preparation of carboxylic acids. So today is the interesting part. We are going to see that how one can prepare the carboxylic acids from grignard reagents. From grignard reagents. Of course, we know what do you mean by this grignard reagents. Yes. So grignard reagents means they are the alkyl or the aryl magnesium halides. Yes. So by utilizing such grignard reagents, we are going to see that how carboxylic acids can be prepared. So first of all, I would just like to give you the general reaction. That is, when my grignard reagents, that is RMgX, is treated with solid CO2. What is that? Solid CO2, which means what? Dry ice. Remember, solid CO2 means dry ice. So in the presence of a dry ether, first of all, you will be getting an addition product. Addition product, of course, we know this will be having a delta plus, R will be having a delta minus. So here now what will happen? Oxygen electrons, whatever the pi electrons are there, that is more being attracted towards the oxygen. So in turn what happens? The carbon gets a positive charge. So this part will be attracted over here. So you will be getting as RC, yes, double bond O, and here Mg plus is there. So that is RCOMgX. So first of all, when you are treating a grignard reagent with a solid CO2, that is your dry ice, in the presence of a dry ether, first an addition product is obtained. Then upon acid hydrolysis of this, what you can say, addition product in the presence of a mineral acid, the final product, whatever you are going to get itself, will be our carboxylic acid, MgXOH. So this is a general funda how one can prepare the carboxylic acids from grignard reagent. I repeat once again. So when you are treating your alkyl magnesium or your grignard reagents with a dry ice in the presence of a dry ether, first you will be getting an addition product. Okay, this is an addition product. Then upon acid hydrolysis of this addition product, the final product, whatever we are getting, will be our respective carboxylic acid. For example, if I am going to take CH3MgI, methyl magnesium iodide, and treating this one with my solid CO2, that is my dry ice, in the presence of dry ether. So first you will get an addition product. What is the addition product? So CH3C double bond O MgI. Then upon acid hydrolysis, that is CH3C double bond O MgI. So upon acid hydrolysis of this addition product in the presence of mineral acid, so what you are going to get? CH3COOH plus MgIOH. Can you see? From methyl magnesium iodide, I have prepared my acetic acid. That is, from a grignard reagent, I am able to get a carboxylic acid. The product is same. That is, the method is same. Yes or no? For example, if I want to prepare now benzoic acid, how can I do? Just in place of R, you write your C6H5. For my convenience, I am just taking my bromide part over here. Okay. In the presence of C double bond O, that is my solid CO2, which means your dry ice, in the presence of dry ether. So what you're going to get? C6H5C double bond O OMgBr. First we are getting an addition product. Then upon acid hydrolysis of the addition product, OMgBr, yes, plus H2O in the presence of an acid, which means what? Acid hydrolysis. I am going to get my benzoic acid. Benzoic acid. Can you see? So this is the funda where we are getting to know that how one can prepare the respective carboxylic acids using your grignard reagents. Is that clear? I hope there is no doubt in it. But I want to ask you a question. What is that, sir? Of course, we come to know that from grignard reagents one can prepare your carboxylic acid. By utilizing this concept, I repeat, by utilizing this concept, can you give me a reaction in which alkyl halide, from which alkyl halide can be converted to carboxylic acid? Alkyl halide can be converted to carboxylic acid. Are you getting my question? Utilizing the above concept, yes, because we have come to know that Grignard reagents, we have got a carboxylic acid. By utilizing the same concept, I am asking you a question. How can you prepare carboxylic acid using an alkyl halide? Yes, of course we know from the haloalkanes and haloarenes chapter. What was that? Grignard reagents can be prepared from an alkyl halide. For example, Rx in the presence of a magnesium metal in a dry ether gives you what? Yes, RMgX. Then treating this RMgX with a solid CO2 gives you an addition product which upon acid hydrolysis gives you RCOOH. So what is the funda over here? The final product carboxylic acid has been derived from an alkyl halide. So that is the reason. This is the way of understanding your organic reaction. For example, if I'll ask you, how can you prepare carboxylic acid from alkenes? How can you prepare carboxylic acid from alkenes? What will be your answer? How can you prepare it? Yes, by the hydration of the alkenes, that is a symmetrical alkenes. For example, if I take CH2 double bond CH2. So in the presence of H2O, what is it is going to give you? An alcohol, CH3 CH2OH, which is what? Primary alcohol. So in the previous video, we have seen that how one can obtain the carboxylic acid from a primary alcohol. So one can easily prepare a carboxylic acid from alkenes by converting that alkenes to primary alcohol. Can you see? So this is the way of analyzing the reactions. So in the textbook, whatever they have been given, that could be asked only for your exams. But in a competitive exams, you have to think in this way. Yes, one method ಗೊತ್ತಿರುತ್ತೆ. You have to go backside of it. Okay, ಈ alcohol ಬರ್ಬೇಕಂದ್ರೆ, is there any other reactant we can get these alcohols? Of course it is. Then you try it. How can you derive it? So that will be giving you a knowledge of conversion of reactions, where you can convert from one functional group to another functional group. Is that clear? You know, the hydroxy group in the we are converting it for carboxylic acid group. Yes or no? So these are called as a functional group conversions, which are very much important in organic chemistry. You getting my point? So we came to know whenever an Grignard reagent has been treated with that of your dry ice in the presence of a dry ether, first of all you will be getting an addition product, which upon acid hydrolysis gives us the corresponding carboxylic acid. Is that clear? So this was the one part where we came to know that preparation of the carboxylic acids from Grignard reagents. So next let us see how from esters. From esters, how one can prepare the carboxylic acid. Very much important, because in this reaction we could just see that it is a conversion from one functional group to another functional group. I will mention once again, in organic chemistry, conversion of functional groups are very much important. Okay, so these are certain important reactions one has to know. So let's begin with the next video. So the next concept, that is how can you prepare the carboxylic acids from esters. So now let us begin with how can you prepare your carboxylic acids from esters. So guys, basically I have to give you one hint over here. What is that? Of course, esters, when they are acid hydrolyzed and even when they are base hydrolyzed, both will be giving you the carboxylic acids, one of the most important thing. But when you are using an acidic medium, it is one step reaction that is directly getting an acid. But when you are using a base, first you will be getting a salt. Then upon acidification of that salt will be giving you the respective carboxylic acid. For example, let us go with it. If I am going to take my ester general reaction, RC double bond O and an R. Yes, ester in a functional group COO. Yes. So first in Martin Nano, acid hydrolysis Martin. There is H2O in the presence of H plus. So of course now this reaction will be directly giving you what? Respective carboxylic acid. And remember, along with that you will be also getting an alcohol. Okay. ಒಂದು ಪಾರ್ಟ್ ಆಸಿಡ್ ಕೊಡ್ತಾ ಉಂಟು, ಇನ್ನೊಂದು ಪಾರ್ಟ್ ಆಲ್ಕೋಹಾಲ್ ನ ಕೊಡ್ತಾ ಉಂಟು. This is in the case when you are doing an acid hydrolysis. But in case if I am going to treat this ester in the presence of base now, RCOO R dash plus NaOH plus NaOH. First it will be giving you sodium salt of an ester. Yes. First it is going to give you what? Sodium salt of a carboxylic acid. Sorry, sodium salt of a carboxylic acid. Then upon acidification, it will be giving you what? Respective carboxylic acid. So in either ways you can prepare. Even by acid hydrolysis also, we can prepare a carboxylic acid. Even by utilizing the base also, we can prepare the carboxylic acid. But one difference you have to maintain, what is that? You have to remember, whenever you are using a base, first you will be getting a sodium salt or whatever the base. For example, if you have used a KOH, you would have got a potassium salt. So generally I will say that you will be getting a salt of a carboxylic acid. Then upon acidification of that salt will be giving us the respective carboxylic acid. But do remember here one of the important byproducts also we are going to get, that is your alcohols. Yes, if I will give you a question, for example, let me take my example as ethyl benzoate C6H5 C double bond O and O CH2 CH3, okay, plus H2O and in the presence of H plus. So what is the product you are going to get? Do remember guys, always the greater number of the carbon atoms will be forming an acid. The smaller atoms will be forming an alcohol. So here you will be getting as C6H5 COOH benzoic acid plus CH3 CH2OH. That is your ethanol. Can you see? If I use a reaction is in this way. For example, another reaction if I choose CH3 CH2 CH2 COO C2H5. That is, I have used ethyl butanoate. Yes, ethyl butanoate. I am going to treat this one with base. So first what you are going to get? Yeah, remember now ikkade iradistu LD carbon atom. Illi iradistu total agi there are 3 carbon atoms. So now this will be forming an acid. This part will be forming an alcohol. Yes or no? So NaOH the treat martini. Along with that one, first what you are going to get? CH3 CH2 CH2 C double bond O and ONA. That is, you are getting a sodium salt of a carboxylic acid. Then upon acidification we are getting as what? CH3 CH2 CH2 COOH. Along with that one, here this part is the alva C2H5. That is C2H5OH. C2H5OH. Of course, this C2H5OH ನಮಗೆ ಇಲ್ಲೇ ಬಂದಿರುತ್ತೆ. Okay, just for the convenience I have written at the last. ಇಲ್ಲಿ OH minus ನ ತಗೊಂಡು that is C2H5 plus OH minus ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ CH3 CH2 CH2 COO minus ಏನಿರುತ್ತಲ್ಲ ಆ minus Na plus ನ ಹೇಳ್ಕೊಳುತ್ತೆ. That is the reason. This C2H5OH will be formed here itself. Just for our convenience, I have written at the last all the important products. Is that clear? So esters, if you want to prepare a carboxylic acid from the esters, there are 2 important methods. What are those? One is direct acid hydrolysis you can do, where you will be directly getting your carboxylic acid. In case if you are doing with the base, first you will be getting a respective salt of a carboxylic acid. Then upon acidification, you will be getting your corresponding acids. Is that clear? So this is one of the important reaction as I mentioned, because it is a conversion of from one functional group to another functional group. That is, from ester you are going to convert it for your carboxylic acid. So the next important method we are going to see is from acyl halides. That is how one can prepare the carboxylic acids from acyl halides. So guys, this is also a simple reaction. If you have come to know that how one can prepare the carboxylic acid from esters, you will easily come to know that how can you prepare the carboxylic acid from acyl halides. It is the same protocol as we have followed earlier. So of course acyl halides general representation is what? RC double bond O and a X. So remember, whenever your acyl halides is directly acid hydrolyzed, what it is? directly acid hydrolyzed, that is H2O in the presence of H plus, we will be directly getting our corresponding carboxylic acids plus HX. Yes. But if you are going to treat the same acyl halides with a base, as I have mentioned earlier, first you will be getting a salt. See here, that is RCOONA. Can you see? So here you are getting a sodium salt of a carboxylic acid. Then which upon acidification, you will be getting your corresponding carboxylic acid. Yes. So the same protocol what we have followed earlier, but only differences with respect to the reactant. So here we are converting the acyl halides to the carboxylic acid. So whenever you are doing an acidification of your acyl halides, you will be getting a carboxylic acids directly. But whenever you are treating your acyl halides with a base, first you will be getting a sodium salt of your carboxylic acid, which upon acidification gives you the corresponding carboxylic acid. Is that clear? Very much important. You have to note over here. Let us have certain general examples over here. For example, if I am taking an acetyl chloride, CH3C double bond OCl. Yes, do it with acid hydrolysis and say me the product what you are going to get. Yes, very good. So here you are going to get what? Acetic acid plus HCl. If I am going to use the same CH3COCl in the presence of NaOH, can you please guide me? First what you are going to get? CH3C double bond ONA. Sodium salt you have got. Then upon acidification, you will be getting your corresponding carboxylic acid, that is your acetic acid. Are you able to note the difference? Of course, by both the ways, you can prepare the carboxylic acids. If you are using an acid, directly you will be getting your carboxylic acid. In case if you are using a base, first you will be getting a sodium salt. Then upon its hydrolysis, you will be getting your respective carboxylic acid. I hope so there is no doubt in it. Okay. This is similar to that of your esters itself. But the only difference is what? The reactants. Okay. In the first case, we have used the esters, whereas in this case, we are dealing with my acyl halides. Okay. Now let us go with another important method and the last method of the preparation of the carboxylic acids, which is called as from acid anhydrides. Acid anhydrides. So it's a simple reaction because just by treating with the water, this acid anhydrides gets converted to the respective carboxylic acids. But how to write this acid anhydrides? Many times I have said you, the general format of writing this acid anhydrides is RCO twice O. Yes or no? RCO twice O. That means what? If I am going to use R, C double bond O, single O, C double bond O and an R. Can you see? So R 2 times are there, C 2 times are there, O 2 times is there and single one O is there. So RCO twice O. So whenever these acid anhydrides are just treated with a water, yes, you will be getting your respective carboxylic acids. In both the cases, RC double bond O, OH. For example, if I use acetic anhydrides, H3C double bond O, OC double bond O, CH3, in the presence of water, what you are going to get? Yes, you will be getting as a CH3COOH plus CH3COOH. That is 2 moles of your acetic acids are obtained. Similarly, if I use my benzoic anhydride, that is C6H5C double bond O, O, C double bond O, C6H5. So when you are treating this one with the water, what you are going to get? C6H5COOH plus C6H5COOH. That is 2 moles of your benzoic acid. What is the thing you have to remember? Just by treating with the water, what is that? Just by treating with the water, it is sufficient that you can easily convert your anhydrides to carboxylic acid. Is that clear? So this completes the different methods of the preparation of carboxylic acid. So let's have a quick recap. So in today's video, we have dealt that how from a Grignard reagent one can easily prepare your carboxylic acid, and we came to know that when you are treating your Grignard reagents with a dry ice in a dry ether, first you are going to get an addition product. Then upon acid hydrolysis of that addition product give you the corresponding carboxylic acid. Is that clear? And also we came to know that about certain conversion reactions. Of course we know that we can prepare such grignard reagents from alkyl halides. So also we can note a point, what is that? Even the carboxylic acids can be prepared from alkyl halide. That is also we have also seen with respect to the alkenes also. That is by conversion of your alkenes to primary alcohol, then upon treating that primary alcohol in the presence of alkaline KMnO4 gives you the carboxylic acid. So these are the certain vital reactions one has to know whenever you are doing a conversion reactions. Is that clear? Then we came to know with respect to the esters. So in esters what we came to know, of course there are two methods of the preparation of the carboxylic acids from the esters. That is by directly doing an acid hydrolysis one can easily convert your esters to the carboxylic acids. But in case if you have been given with a base, first the ester will react with the base to form an sodium salt of the respective carboxylic acid. Then upon acidification of that salt will be giving you the final carboxylic acid. Yes. Of course we came across with certain examples over there and we came to know that how one can prepare your benzoic acid and also your butanoic acid. Then we came to know with respect to the acyl halides. Yeah. So the first of all we have to know whenever we are writing these reactions, first the general format we have to know. And we know that the acyl halides are represented as RCOCl. If it is an acyl chloride. General acyl halides means it is RCOX. Yes, recall your Rosamond reduction reaction. There also we have used certain acyl halides itself. Alva, the same acyl halide we are using over here also. So Elaine Marthidivi RCOX, when it is doing with an acid hydrolysis, directly you will be getting your carboxylic acid. But in case if you are treating with a base, first you will be getting a sodium salt of a carboxylic acid, which upon acidification gives you the carboxylic acid. Is that clear? Then coming to the another important part, that is from acid anhydrides, and we came to know the general formula as RCO whole twice O. Alva, that is RC double bond O C double bond O R, where you can just see that RCO is 2 times and a single O is just 1. Alva. So just by treating with a water you can easily convert your acid anhydrides to corresponding carboxylic acid. Is that clear? So these were the certain important methods and we came to know how to prepare the carboxylic acids from a primary alcohol, from esters, from grignard reagent, from alkyl benzenes, even from that of your cyanoalkenes. Yes. So these were certain important reactions, because one of the most important thing lies over here is we can able to convert from one functional group to another functional group. So it becomes one of the vital reactions to know. Yeah. What is the utilization of your strong alkaline KMnO4, potassium dichromate, Jones reagent, that is your chromium trioxide in an acidic medium. So much things we have come to know in these methods of preparation. So make a note of all these reactions. Okay, very much important both for your exams and also for your competitive exams. So in our next video we are going to see about the acidic nature of the carboxylic acid. So whenever we talk about a carboxylic acid, of course we say it's an acid. But the question arises within us, why it is an acid? So that will be answered in our next video. But I will be giving you a homework. You please come prepared with the resonance structure of the carboxylic acid for the better understanding of the acidic nature of your carboxylic acid. I repeat, it's a homework for you. As soon as you have seen this video, understood this video, when you are attending the next video, come prepared with the resonance structure of the carboxylic acid. And by utilizing that resonance structure itself, many of you will come to know that before I am explaining it, why the carboxylic group is an acidic group. Is that clear? The overall answer lies in the resonance structure of our carboxylic acid. Is that clear? Which will be seen in our next video.